So in our previous class, we started discussing about IPv4 addressing and its logics, like how to convert binary to decimal and IPv4 range, total range of IPv4 address, and 4.3 billions of IP addresses is classified into 5 classes like A, B, C, or reserved for LAN and WAN, Class D, reserved for multicast, and Class E, research and development. So how to identify a class? So by seeing a range, we can identify a class. So 0 to 127, any IP will comes under class A, like 128 to 191, class B, like
We like.
we can identify IP addresses classes. Agree?
Yes.
Okay. Then let me take one example. One 129.8.2.9. This IP belongs to which class?
Class
Class B.
B.
Network ID?
It's
29.
129.
129.
8.0.0.0.
8.
Dot 8.
Okay.
Dot
0.
0. Dot 0.
Two.
Broadcast ID?
29.
129.8.255.255.
In between IP addresses. Network ID and broadcast ID in between IP addresses, what we called?
Valid.
Valid IP addresses. Usable IP addresses. 65,534. So 129.8.0.0, what we call this is? Say
ID.
network ID. 129.8.255.255 is what?
Broadcast.
Broadcast ID.
So valid IP address will lie between the network ID and broadcast ID.
Yes.
See, this is one device. Device 1, device 2. Two devices are connected directly. So for device 1, IP address 10.10.0.0.0. So this address can I assign for computer? Can you use it?
No, sir.
No, why?
It's a network ID.
Network ID.
It's a network ID we can't use. Okay. Can you use 10.0.0.1?
Yes, sir.
Yes, we can use. But it is not recommended actually. It is first usable IP is recommended for
Route.
the router. Okay. So what I'm doing is for computer 10.0.0 dot 2, 3, 4 or 10. 10.0.0.10 for device 1. For device 2, IP address have assigned like this: 10.186.192.4. For PC1, IP address is 10.0.0.10. For PC2, IP address is 10.186.192.4. So like this, if I assign now device 1, device 2, will they communicate? Yes or no?
Yes.
Okay, this is one case. In second case, device 1 IP address is 172.18.9.2. For device 2, 172.19.9.2. 9.3. It is 9.2, it is 9.3. Now in second case, will they communicate device 1 and device 2?
think so.
Okay. In third case, first device IP address have assigned in 192.168.6.9. For device 2, 192.168.7.9. Will they communicate? So this is the logic we need to understand, guys. So what is the logic here? It is to communicate all devices in your network. All devices should be in same network address. Your device 1, device 2 should be in same network. Like you have 10 devices. So all devices in the network should be in same network. So how to understand devices whether are in the same network or in different network is, I'll give one general example. See, in apartments and buildings, what is 203 indicates?
It's flat.
Okay.
Second floor, third room.
Second floor, third room. Right. Excellent. So 203 means second floor, plot number 3. So here, what is 2 indicates?
Floor,
Floor.
Floor number. Yes. 01, 02, 03 indicates what?
room numbers.
Room number. Okay. So this flows is nothing but is more similarly your network portion. Room is nothing but your host portion. So all devices should be in same floor. I mean, all should be in same network. See now, 201, 202, 203, 204 is all are the same floor. Floor number is same, right? 2. Correct? Yeah. Now, let's compare our IP addresses. So first IP address belongs to which class?
A.
Class A. For class A IP, first octet is
Network.
Network.
network portion.
Network.
Portion. Now, first device is the 10th floor. Second device is also a 10th floor. Now, device 1, device 2, both are in same floor or different floor? I mean, both are in same network or in different network?
Same
Yeah.
network.
Same network.
Same network portion. It's the 10th network, it's also a 10th network. So host can be any number. Here 0010, here 186, 192, it can be any number actually.
Okay.
So network portion is same. So will they communicate or not?
Yes.
Yes, they are in same network, they can communicate actually. Got it?
Yes.
Next example. It's a class B. So class B, first octet is what? Network,
Network.
network,
Network.
network,
Network.
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 So it's 172 18th floor. It is 19th floor. It is the 19th floor. So it means it is 18th network. Yes. Device 1, device 2, both are in the same network or in a different network. What? In second case.
Different networks.
Network portion is different, right?
Yes.
So here, class B, 2 octets are network portion. So means 2 octets should be same. Here, first octet is 172, 172, okay. But second octet is what? It is 18th. It is
18, 19.
19th. So same or different? Different network. So they didn't communicate actually. Clear?
Yes.
So for example,
the B 172.18, right? Whereas if you look at 2.19, so you mean to say that 172.18 supposed to be 18.9.3? Then it can be communicated?
172.18 here, 172.19, right? So
Yeah.
these two octets, these two portions should be same. Means
Oh, okay.
want to enable communication, like at 19, the title change is 18.
Okay.
Now they can communicate actually.
Okay. Got it. Thank you. Thank you.
Network portion should be same. In class C example, first octet is only network. So we have focused on only in first octet, 10, 10. But for class B, first two octets are network portion. So we need to focus two octets. First two octets, 17 to 18, here 17 to 19. It's a different network. They don't communicate actually. Still, if they need a communication, possibilities are what? Make them into same network. So assign IP address 17 to 18 here means is also 17 to configure 18 or here 19.
Okay.
But
Thank you,
my
Bharat.
requirement is, yeah, by my requirement is I don't want to change the IP address, but still I need a communication. Then for first PC, IP address should be 172.18.9.2. For second PC, 170.19.9.3. So without changing IP addresses, still I need a communication. Then
Router.
excellent router. So what is the purpose of router? Yesterday we clearly discussed now. Router is a device which enables communication between
Different networks.
two or more different networks.
Networks.
So now this is in one network. What is the network ID of this IP address? 172.18.0.0. For this network, 172.19.0.0. Both are in different networks now. So for different networks communication purpose, in between these two devices, if we use a router, then they can communicate actually. Right? Yeah. Next point. Is a class C example. Last 192.168.6.9, 192.168.7.9. So if I assign like this, will they communicate?
No.
Why?
Network is different.
Network portion is in different network portions. Yeah. For class C, first three octets. Now you focused on first three octets.
Yes.
Network,
Host.
network, network. So 192.168.6. Here 192.168.7. Different network portion. Will they communicate? No. Okay, I'll do one thing. I'll change network portion. I'm making as both are same network portion as 6. Now will they communicate?
Yes.
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 No.
It's the same IP address, right?
Same IP
Right.
address. IP conflict will come. See 192.168.6.9, 192.168.6.9. IP conflict. So how we can assign one IP address for two computers in the network? No. Network portion should be same. Host portion should be unique number. So can I repeat one more floor for same floor 202, one more room? Already have a 202. So can I repeat one more 202? No. So here also, like same IP address we cannot assign. Network portion should be same. Host portion should be any other number you can use. 6.9, it's a 6.8. Now? Yes.
Yes.
So IP conflict also should not be there. We need to clearly we need to check that actually. So these are all the logics we need to keep in mind to work with IP addressing real networks. Got it?
Yes.
So same example. Device 1, device 2. First device IP address 10.2.9.8. It's 10.3.4.5. In second case, 172.16, 172.16.8.9. Neighbor computer 172.18.7.9. In last case, 192.168.1.2, 192.168.1.3. In first case, device 1, device 2, will they communicate?
Yes.
Yes, sir.
Answer is yes. Okay. Second case,
No, sir.
No.
in third case.
Yes.
Yes, sir.
Yes.
So how we can say first case, yes, they can communicate.
Because network portion
Same
is same.
network.
How we can say both are same network portion?
Because it's a class
First
A
octet.
and it
It's a
was
fast
using
octet.
First octet.
Yeah, octet comparison. It's a class A, correct? As a user, you know that ranges actually. Class A range and class A octet format, you know. So class A, first octet is network, host, host, host. So one octet is network portion. And then you're comparing first octet here, and both are same. So this format, you know, this logic, you know, as a user. But my question is, how really devices can understand? So it is the main logic. How devices can understand? So first octet is my network portion. So I'm in a 10th network. My neighbor is also 10th network, and 2 is my host, 9 is my host, 8 is my host. Like how device can understand it? That is the main logic in IPv4. Yes,
By defining the subnet mask.
correct. See, the same logic. What are the logic here? Class A, network, host, host, host. The same logic we need to tell to devices also. So device also need to understand the same logic. How device can understand that the logic is? What is class A format? First octet is what?
Network.
Network,
Host.
Host.
host,
Host.
host,
Host.
Host.
host. Okay. First octet. Each octet, how many bits?
8.
8, 8, 8, 8. In zeros and ones, 1 indicates network bits. 0 indicate what?
Host.
Host bits. So 1 indicates network bits, 0 indicates host bits. Here, class A first octet is network bits. Like how many network bits? 8 network bits. Means how many ones here? 1, 2, 3, 4, 5, 6, 7, 8. Dot. Second octet is what? Host bits. How many host bits total?
8.
24.
24, like 0, 3, 3, 4, 5, 6, 7, 8, dot, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So this is a binary long ways. Let's convert into decimal. Like what is all ones value? 255 dot, all zeros, 0, all zeros, 0, all zeros, 0. So this value we called subnet mask. So based on subnet mask, device can understand which octet is a network portion, which octet is a host portion. So 255 means wherever you write 255, 255 indicates what?
Network.
Network. 0 indicates what?
Host.
Host. 0 indicates host. 0 indicates host. So by assigning subnet mask only, devices can understand which octet is a network portion, which octet is a host portion. Okay. So subnet mask used to differentiate network and host portion is a class A example. Then what will be the class B for subnet mask? For class B networks, class subnet mask
Network.
255.255.0.0.
255 dot 255
255
dot
dot
0 dot 0.
0 0.
Yes.
Yeah. For class C,
255 dot
55.255.255.0.
255.0.
yes. Okay. See, for example, is a class A IP address. For class A IP address, what is the subnet mask? Class A IP subnet mask 255 dot 0 dot 0 dot 0. Here also 255 dot 0 dot 0 dot 0. So now by seeing subnet mask, device understand which octet is a network portion, which octet is a host portion. So 255 indicates what?
network.
Network. Now your PC understand by seeing 255, oh, first octet is a network portion. Again, second octet is what?
Host.
0. So now device understand, oh, my second octet is host. Third octet is host portion. Fourth octet is host portion because you have assigned 0, 0, 0, right? So by seeing subnet mask, devices can differentiate which octet is network portion, which octet is a host portion. Same like 255.0.0.0, then our neighbor PC also understand first octet is N, H, H, H. Now device 1 will say, I am a 10th network. Yes, I am also 10th network. We are the same network. We can communicate. Yes. Got it? Yeah. So here the main thing is subnet mask is the logic action. Similarly, for class B,
One question.
yeah.
Will there be an option to, to put subnet mask like, I mean,
No,
for
it's mandatory.
it's mandatory. Okay.
Because of subnet mask, if subnet mask is not assigned, then how device understand? Here,
Okay.
out of 172.16.8.9, out of 4 octets, which octet is network portion, which octet is a host portion, how device can understand it?
Okay, so before assigning the IP address, we need to put subnet mask, right?
No, after sub IP address.
After IP address. Okay, so in the software, it's going to be present to submit the subnet mask, right?
Yes, yes,
Okay.
yes.
Okay.
In Windows machines, by default, will take.
Okay. Thank you, sir.
But every IP address must be assigned with subnet mask. Okay. So for class B, is a class B, then subnet mask
255.255.0.0.
255.255.0.0. So by seeing the subnet mask, device understand first octet is network portion. Second octet is also network portion because of we assign 255, 255. And device understand 80 is a host, 9 is a host. Like this. We'll compare to neighbor computer. What is neighbor computer? IP address 172.18 is a class B. Mask is 255.255.0.0. Right? Then it's 172 is network. 18th is network. I am 16th floor. I'm in 16th network. You are 18th network. You are in different network. We don't communicate. They don't communicate actually. Got it? So for class B network, subnet mask 255 dot
255,
255 dot
255.
255.0. So 192 network, 168 is network, 1 is network portion. 255.255.255.0 NNNH. Yes, we both are same network portion. We can complete. And even we don't have any conflict also. I'm at second, 2 is host, your 3 is host. Yes, they can communicate. No conflicts.
Excuse me, sir.
Yes, please.
Can't class B devices communicate with class C devices?
Router, via router. Through router, it can communicate.
It can.
Yes.
It's the same case now also, right? Like without router, the class C, both of the class C devices won't communicate with each other.
In this case, yes, they can communicate, right? Because same network portion.
Okay, then like class B can't communicate because both are in different floors and
Yeah, even both are in the same classes also, but network portion is different, so they don't communicate actually
communicate.
without router.
Okay.
It doesn't matter classes actually here. Only thing is network portion.
Okay, got it.
So like this is all the logics to understand in IPv4 address actually. Okay. I'll take the 3 examples. One 121.8.26.9. Which class IP address it belongs to?
Class
Yes, sir.
Network ID, please.
128.0.0.0.
121
Sorry,
121.0.0.0. Broadcast ID.
121.255.
In between all IP addresses.
Valid IP address.
Address.
How many valid IP in between for class A network?
16777 minus 2.
214. Okay. And what will be the subnet mask for all IP addresses?
55.0.0.0.
55.255.255.
So if we take any IP address, there must be a 4 parameters, guys. First one is 121.0.0.0. So what we call this is the network ID. 121.255.255 is what? Broadcast ID. Valid IP address, subnet mask. These 4 parameters must be there. Repeat, network ID, broadcast ID, valid IP addresses, and subnet mask. 4 parameters, okay? Next. 172.30.2.9. Which class IP address? Say,
Class B.
Class B.
class B. Network ID.
172.30.0.0.
30.0.0.
172.30.0.0.0.0.0. Next. Broadcast ID. 172.
172.30.255.
255.255.255.
Yes. Valid IP addresses.
65534.
In between 65,534 IPs are valid. Subnet mask.
255.255.0.
Okay. One 192.168.5.9 is class IP address.
Class C.
Class C. Network ID, broadcast ID, valid IP address, subnet mask. Quickly.
192.168.5.0.
192.168.5.0.
Okay.
192.168.5.255.
254 valid IP addresses.
254 valid IP addresses. Okay.
255.255.255.0 subnet mask.
255.255.255.0 is a subnet mask. Right. So these are all the logics we need to keep in mind, guys, in IPv4. Any more doubts?
As you said, you're going to send out the handouts, right? So this definitely that will be helpful for us to understand more in depth what you are teaching at you.
What is it?
The handouts for exactly what you are
Okay.
showing. The handouts, what you said, like God.
You can take a screenshots, or I'll share that web links
Okay.
for this
sir.
document. This
Yes,
document.
please.
I'm asking for the documents, whichever you have displayed. Any prior prepared kind of documentation also good help for us.
Yeah, I'll try to share it.
Thank you.
Thank you.
You can check assigning IPv4 address to computer. So if you open the run box and type ncpa.cpl, enter, and for Ethernet adapters, you can right click, properties, IPv4 properties. So here we can assign IP address for class A IP or class B IP, whatever IP address you're using, you can assign here actually. So example 121.3.4.21. 3.4.21. So second line is what? He's asking subnet mask.
Submarking down.
If you
Okay.
press tab, it will fill automatically actually. 255.0.0.
Okay.
So you want to modify IP address, you just click on the top, again click on the bottom, use the following IP address. Now, as
172
for example, 172.30.23.14. Subnet mask will be
255.255.
yes.
Zeros.
Yeah.
So if we change IP address dynamically like this, do we got any impact on the machine or other things?
Yeah, if you change the IP address, you'll lose your communication now. See, what is the IP address is existing now? It is with that IP address, it's getting communication with all your infrastructure. If you change IP address, then how they can communicate? They don't communicate, right?
The internet
Yes.
Do a kind of way. So is there any other alternative we can do? Play around and understand how this IP address works. Is there any other alternative way? If we do anything on our computer, might be the address change or IP address change or anything.
Yeah.
Maybe
For practices, we have a software to do some practices assigning class A IP between two devices or class B IP or different IP addresses. So packet tracer tool, you can use it.
what is
And
the tool name? Can you please
tell-
type?
Yeah. You can see this is Cisco Packet Tracer Student app.
Once again. Load it, right? Is it a free download or like?
Yes, yes, free. So any more doubts in IPv4 address? Let's continue with IPv6 now, okay? So IP addressing is two versions. IPv4 and IPv6. Now we are surviving with IPv4 only, but why IPv6 is required? What is difference between IPv4 and IPv6? See, IPv4, so when IPv4 was developed at the time, internet users are 10,000 users. But IPv4 develops how many IP addresses IPv4? 4.3 billion IP addresses, right? Total IPv4 addresses. So what developer thinking is, like today, internet users are 10,000 users, but now we developed 4.3 billion IP addresses. So in coming generations also they can be survived, like they are thinking actually. And what happens suddenly, like internet uses websites, number of websites, equipment, technology, it grown up very heavily. Billions of billions users are connected in internet over, correct? So we don't have IPv4 addresses. Even in IPv4 also, class D IPs we are not using, and even class E also, only ABC. So all 4.3 billions are not used. Only ABC classes we are using. Then how we can survive with that IP addresses only? So you are out of IPv4 address. We need a more number of IP address. That is the main reason IPv6 was developed. Is we need a more number of IP addresses. Currently, we are out of IPv4 address. We need a more number of addresses. So for that, IPv6 has been developed, which is with 2 power 128 combinations. With 128 bits, IPv6 is designed. IPv4 is 32. IPv6 is what? 128 bits. Means 2 power 128 combinations of IP addresses. In IPv6, trillions of trillions IP addresses for each person in the planet. Not total IPv6 addresses. No, for each person in the planet. I have reserved trillions of trillions IP address. For you, yes, for everyone, for each person in the planet, we have trillions of trillion IPv6 addresses are reserved. So that many IPv6 are reserved, available actually. Okay. So let's see differences between IPv4, IPv6, how to understand IPv6 address also. IPv4 is 32-bit address. IPv6 is 128. IPv4 32-bit address is divided into, it is a decimal format. IPv6 is hexadecimal format. In decimal, octet format is divided, right? One octet contain how many bits?
8.
8 bits. Like IPv4 is divided into 4 octet, which is 32-bit. What about IPv6? And IPv6 128 bits is divided into quartet format. In IPv4 we call it as octet. In IPv6 it is quartet. One quartet is 4 hexadecimal numbers. Like IPv6 should be 8 quartets, just having 32 hexadecimal numbers. In IPv4, first octet, second octet, third octet, every octet is been separated by using dot. In IPv6, first quartet, second quartet, like 8 quartets are separated by using a colon. So here we use dot, here we use colon actually. This is differences IPv4 and IPv6. IPv6 is 128-bit address. It is represented as 32 hexadecimal numbers arranged in 8 quartets of 4 hexadecimal digit separated by colon. Like this. This is first quartet, second quartet. Like it should be 8 quartets. In IPv6, A, B, C, D, F not case sensitive. Okay. So IPv6 address in hexadecimal. This is example of IPv6 address. This address we need to assign for a computer actually in IPv6. Okay.
I have a small doubt.
Okay.
In IPv4, we are used to separate with dots, and IPv6 we are using a colon. We can use why we are not using dots, and we are using colon over there.
Already used dot, right, in IPv4.
Yeah,
So in IPv6 colon.
to know the separation of IPv6 and IPv4.
Separation?
I mean, to notice the IP address.
Yes.
Okay.
See, I'll give some statements of IPv6. Understand this. 1 hexadecimal, which is equal to 4 bits. Four hexadecimal is equal to 1 hexadecimal is 4 bits. Then 4 hexadecimals,
16.
1 quarter.
16 bits, or we can call 1 quartet. Yeah, correct. Then 8 quartets. 8 quartets contain how many hexadecimal? How many bits?
32 hexadecimal.
Bits is 128. How many quartets?
32.
32 quartets. So we can say this is 8 quartets is what IPv6. Correct? So let me explain the first statement. What is the point number 1? one hexadecimal is equal to 4 bits. Like how it can come is, I'm writing hexadecimal numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10A, 11B, 12C, 13D, 14E, 15F, 15F, right? So these all are hexadecimal numbers. One hexadecimal is 4 bits, so I'm taking the 4-bit value. That's 2 power n, 4 bits I'm using here. So 2 power 0, 2 power 1, 2 power 2, 2 power 3, 4 bits. Any power 0, 1, 2, 4, 8. 0 indicates, 1 indicates,
0 indicates host.
off. 1 indicates, on.
On.
Then how we can write 0 in binary? How we can write 0 in binary? 4-bit value. 8 should be off, 4 is off, 2 is off, 1 is off, like 0, 0, 0. Then how can I write 1 in binary? 0, 0, 0, 1. How can I write as 2? 0, 0, 1, 0. What about 3? 0, 0, 1, 1. 4, 0, 1, 0.
0, 0.
Correct. How can I write as 5?
0, 1, 0.
0,
0,
1,
1,
0, 1.
0, 1. 6,
0, 1, 1, 0.
0, 1, 1, 0. 7, 0, 1,
1,
1,
1, 1.
1. 8,
1, 0, 0.
1, 0, 0, 0. 9, 1,
1,
0,
0,
0,
0, 1.
1. Like one hexadecimal is equal to 4 bits. If you take any one number, it is equal to 4 bits actually. Same here also. 8, 4, 2, 1. And how can it is A? A is 10. 10 means 1, 0, 1, 0. B is 11. 11, how can I write as 11? 1, 0, 1, 1.
1, 0, 1, 1.
How can I write as C? 12,
1,
1,
1,
1,
0, 0.
0, 0. What about 13?
1, 1, 0, 1.
1, 1, 0, 1. 14, 1, 1, 1,
1, 1,
0.
1, 0.
15, 1, 1, 1,
1,
1.
1.
Yeah. So like this we can understand converting binary to hexadecimal. Okay, or hexadecimal to binary. Whatever. In IPv4 starting, we have seen how to convert binary to decimal. Here, binary to hexadecimal. Next point, IPv6 example. 4 hexadecimal should be 1 quartet. Like we need how many quartets?
8.
8. 2018 colon, because it's the first quartet. See here we have four hexadecimals. 1, 2, 3, 4. right? 201A colon 002C colon 0000 colon So this is one IPv6 address, correct? This is first field, second, third quadrant, fourth field, fifth field, 6, 7, 8. 8 quadrants is IPv6 address. So how we can understand this IPv6 address and how can assign IPv6 address per computer? Correct. See, we have some rules to represent IPv6 address. So by using that rules, we can simplify this actually. Rule number 1. From any field, from any quadrant, leading zeros can be omitted. Leading zeros can be omission. You can remove, optional. Leading zeros. Like in first field, 201A, we don't have any leading zeros. Can't do anything actually in first field. Second field, 002C.
Yeah.
So starting leading zeros, now we can omission it, we can simply can write as 2C this is. Even in sixth field, 0000F, you can omission these all zeros, you can simply can write F. Even if you write F, your device understand there are zeros before actually. Automatically device can understand. Then why we need to write that optional bits actually. Okay, this is rule number 1. Rule number 2. Rule number 2 is 4 successive zeros. It can be any field, it can be any quadrant. 4 successive zeros substituted with single zero. Wherever 4 are zeros, 4 are successive zeros, so that 4 successive zeros is can substituted with what? A single zero. Even if you write single zero, your device can understand, oh, there is a there are 4 fields of 4 zeros actually, like that. So using these two rules, tell me how can represent this IPv6 address?
201.
201A colon
201A colon
2C
2C.
why 2C?
before
Uh,
20
Leading two zeros are omitted. Okay. Next.
F.
0
Colon
F.
colon 0
0.
0.
colon
0.
Why
0
colon
0.
0?
Okay. 4.
4
4
successive
successive zeros substituted with single zero.
yes
Colon
colon 0
0. Colon
colon 0
0. Colon
colon F
F.
colon 0
Colon
colon 0
0. Colon 0. Like this we can
yes sir.
you can represent IPv6 using these two basic rules. Rule number 3. Rule number 3 is multiple fields of zeros. Multiple fields. 2 fields are zeros, 3 fields are zeros, 4 fields are zeros, 5 fields are zeros, 6 fields, like multiple fields are zeros represented with double colon. Multiple fields, like here 2 fields, here see you can see here 3 fields. So multiple fields of zeros we can represent what? Double colon. See in IPv6 address, double colon indicates multiple fields of zeros. It can be 2 fields, it can be 3 fields, it can be 4, it can be 5, it can be number. Tell me, using next rule, rule number 3, how can represent this IPv6 address?
201.
201A
colon 2C
colon 2C
double colon F.
double colon F
double colon.
Double colon.
Double colon. Okay. See, this IPv6 address I have assigned to one device. Generally, how device can understand? IPv6 should be how many quartets?
8 quadrants.
But how many we assigned? 1,
Two.
2,
3,
3.
how many are missing?
5.
5.
Where is 5 fields, man?
A double colon is representing that.
Means here is a 5 fields, or here is a 5 fields. So here is a 2 fields, or here is a 3, or here is a 3, here is a 2. Where exactly 5 fields?
Okay.
Device confused. So that's invalid IPv6 address. Say invalid. So rule is multiple fields of zeros we can represent the double colon, but only once in a address. The double colon rule you have to use only in once. Either you can replace here, I can represent it here, or you can represent here. So we cannot use it multiple times actually, only once in a address. So because of we have repeated multiple times, then it is invalid actually. Okay. Tell me now, how can finally can represent this? 201A
A
colon
colon 2C
2C double
colon
colon
F
F
F
colon 0 colon 0.
colon 0 colon 0. Yeah. Now this IPv6 address I have to assign for a device. Now what device understand here? How many fields we assign? 1, 2, 3, 4, 5 we assign, right? How many are missing?
3.
Then your device automatically can use, oh, here double colon, in double colon, remaining fields are zeros. How many remaining? 3 fields.
3 fields.
So 3 fields are zeros. Your device will understand automatically. The device can be any device. It can be PC, it can be router, it can be firewall, it can be any device to understand actually. Clear? Omission of zeros. Leading zero in any quartet can be omitted. 4 successive zeros in a quartet can be substituted by 1 0. Multiple quartet with zeros can be represented as double colon, but only once in a address. Clear? Do one thing. Try to answer this. Then you can get clear. First one. Represent
001
2001
colon DB8 colon 1
colon DB8 colon 1 colon 1000.
We can put double colon.
Yeah, here you can put double colon, right?
Yeah.
Here.
double colon
Double colon
EF0
EF0
double colon PC
PC.
double zero.
PC 0.
PC 00. Only leading zeros we can omission, not next zeros actually, right? Only leading zeros. Second example.
2002
002
Colon
colon
002
1111
1111
colon 4CF
colon 4CF
double colon
double colon
colon 2F.
double colon
double
double
colon
colon 2F
2F
2F. Yeah, that's all. Is 1, 2, 3, 4 fields are represented with simply double colon actually.
Yes.
4 fields we assign. And remaining 4, your PC understand where you mention a double colon, there you can place 4 fields of 0 section. Next example.
3
F,
F,
Triple F,
3 triple F,
double
double
colon,
colon,
5D,
5D,
double colon,
5D,
5D,
colon
colon
0,
colon
0,
0, colon 9
colon 9C.
CE,
right. Next example. 2001,
double colon,
double colon,
double colon,
FACE,
CE,
FACE,
colon,
B000,
colon, B, colon, BC,
B00C,
B00C, colon
colon
0,
0, colon 0,
double colon.
colon
69.
69. No, colon 0, colon 0.
Why?
Colon 0. We already used
We
one.
already assigned double colon.
Already used double colon. The rule is only once in address. Colon 0, colon 0, colon 69. Yeah.
excuse me.
Yes.
Sir, in B 00C, two
Hmm.
leading zeros are there, na?
Where is leading 0? Starting B is there, right?
Oh, okay.
So
Not in between.
here,
Okay.
not in between, only leading, only starting
Starting.
zeros, only can omission. Yeah. Have it 10 rupees. 0, 1, 10. So can you omission this 0? No, only leading 0. You can write as a 10 actually. 0, 0, 0, 25. Value is what? 25 only. Like 0, 0, 305. Can you omission middle 0? No. So value is what now? 305.
305.
Only leading zeros you can omission.
Okay.
Right. Next example.
20 dB,
20 dB,
colon 0, colon 0,
20 dB,
colon
colon
0,
0,
colon 0,
colon 0, colon 0,
colon
666,
colon 6666,
double 6, double
double
colon,
colon,
double colon,
5288.
5288. Okay. Two zero dB, double colon, 6666, colon 0, colon 0, colon 0, colon
5228.
522. Can I write like this?
yes sir,
Yes.
Which is valid? First one is valid or second one is valid?
both are valid.
Both are valid.
Both are valid. Even the given example is also valid, right?
Yes.
Yeah. But instead of replacing 2 fields, better to replace 3 fields. Correct?
Yeah.
Yes.
Yes sir,
Yeah. So last example.
2001, colon double
2001,
Colon, double one, double one.
colon 1111,
colon double colon,
double colon 1.
1.
Double colon 1. Yeah.
That's
Simple. So 128 bit of IPv6 address, 32 hexadecimals of IPv6 address, 8 quartets of IPv6 address. Finally, we simplify like this. Easy, IPv6?
Yeah.
Yeah. So if you understand the logics, everything is simple, guys, actually. So using these basic rules, we can represent IPv6 address, and we'll continue with one more logic. See, device 1, device 2 are connected. For device 1 IP address 192.168.2.5, 192.168.2.5. 3.5. In IPv4 case, will they communicate?
No.
No.
No. Why?
No. ఎందుకంటే ఇక్కడ 3 ఉండాలి.
If it is also 2.5, then
Class B.
No.
Yes, it will communicate.
No, sir. IP conflict. Conflict.
IP conflict. If it is
Must not.
52,
It
Yeah,
can
they
be.
can communicate.
It can be.
see, actually, this is not my question, because this logic already from yesterday to till today we are discussing a lot of examples. But actually, my question is this. The question is 201A colon 2CF double colon 29 is for first computer IP address. For second computer IP address is 201A colon it's 2CD double colon 29. Now in IPv6 case, tell me, will they communicate or not? Yes or no, or we don't know. What is the right answer?
We don't know right now.
We don't know.
We do not know.
Yes, because in IPv4 we got the logics, all the logics. Then we can clear, right? So,
Yeah,
and
safe,
moreover
right.
in IPv4 we have classifications. It's a Class A IP, Class B IP, Class C, Class A octet, first octet is network, Class B, first two octets are network, Class C network and host. But we don't have any classifications in IPv6. No classifications, A, B, C, D, no like that actually. Then how we can understand IPv6 whether in the same network or in different network is, in IPv6 you have only one logic. So logic is, let's try to write this IPv6 address in 8 quartet format first, okay? I'm writing as 8 quartet format, 201A colon 2CF colon 0 colon 0 colon 0 colon 0 colon 0 colon 29, right? What about for a neighbor computer? Also same, but it is 2CD, correct? Remaining same actually. Okay. See, IPv6 is how many bit address?
28 bit.
128. Out of 128, first 64 bits and next 64 bits. First 64 bits indicates network portion. The last 64 bit indicates host portion. So this is only the logic in IPv6 actually. Only one logic. Network portion, host portion. That's all. Like no classifications. Class A, first octet, Class B, 2 octets, Class C. Not like that. Out of 128, first 64 bits are network portion. Second 64 bits are host portion. So first 64 bits means how many fields? How many quartets?
4.
4. So first 4 is 201A, 2CF, colon 0, colon 0. So till here it is the network portion. For neighbor computer, 201A, colon 2CD, colon 0, colon 0 is the network portion. Now I can compare. It's 201A is also 201A. It's a 2CF, it's a 2CD. So both are same or different?
Different, sir. Not communicate.
Different, not communicate. Still, if you need a communication,
Router should be used.
Router.
so router is a device which enables communication between two or more different IPv4 network and IPv6 network also. The router has that much like intelligence to communicate different IPv6 networks and different IPv4 networks. Okay.
A quick question here. When a
Yeah,
system I assign a IP for IPv4, also system also assign IPv6, correct?
Yeah.
So we know that like system IPv4 has a limited about like maybe in a millions or kind of systems are there. When it goes to IPv6, the billions, right? Does it match what millions versus billion? How that takes
See,
place.
actually, one device is assigned with IPv4. Another device is assigned with IPv6. They don't communicate actually. One device with IPv4, another device with IPv4 to IPv4 communication. IPv6 to IPv6 communication. Not IPv4 to IPv6.
But when you look into the system, any kind of when you log into a system or a network, you see IPv4 address and also IPv6 address also there, right?
But IPv4 is working. If you
Oh.
see without IPv4, only IPv6, then your computer is running with IPv6.
Mhm.
If you see both means IPv4 is a primary. IPv4 is working there actually.
Thank you. Thank you.
So in IPv6, logic is first 64 bits are network bits. So means first 4 quartets are network quartets. Remaining are host. Now here they don't communicate. You want to communicate, you can change this portion, network portion. I'll make it as 2CF here. I'll make it as 2CF here. Now will they communicate?
No,
No.
same host.
Same host. Host portion should be unique now. So now in the host portion you can change on 5th field or 6th field or 7th field or 8th field. Any field you can change. Generally it is 20, 29 and it is 30. Now will they communicate?
Yes.
Yes. You can communicate. No more doubts? In IPv4 case, will they communicate device 1 and device 2 in IPv4?
Yes.
Yes.
Yes. So how they can communicate in IPv4 case? Because both are in
Network.
same network. How device can understand both are in same network? Because of what?
Subnet.
Subnet mask.
Subnet mask. So that is 255, 255, 255.0 like we can assign. Similarly in IPv6 case, like how device can understand network portion, host portion. In IPv6 also required a subnet mask, but in IPv6 terminology we call it is subnet prefix length. Subnet prefix length. So what is the network bit length in IPv6?
64 bits.
64, like you can indicate /64 /64. So this /64 is similar to subnet mask of IPv4 address. In IPv6 we call subnet prefix length. I'll show you how to assign IPv6 address. Same like ncpa.cpl, Ethernet, right click, properties, IPv6 properties. You choose IPv6 properties. Like here you can use the following IPv6 address 201A colon 2CF double colon 29. And the next line subnet prefix length is 64. So my machine can understand for 64 bits are network bits. Yep. Got it? So
Yes.
it's all about for today. So successfully we have done with IPv4 and IPv6, and still few more points are left. Tomorrow we'll continue with that. Thank you. Have a good day. Yes, please. Hello.
Hello.
Yes.
Sir, can you please share that slide?
Yeah, I'm preparing a group. Once group is done, then I'll share in group, okay? Thank you.
Hello, bye.